I'd like to start with your background. How you got into this field of physics in the first place, and could you please, tell us maybe was there some sort of particular fascination with physics when you were studying in school, or when you were like young
So
kid?
actually, I really liked math when I was a kid. I like solving problems. I like puzzles. And I wasn't sure if I would do math or physics, but I did like the idea of doing something that would apply to the real world, that we would describe phenomena in the world. And so in the end, I decided to study physics. But I wasn't positive I would do it, but I thought if I decide to do something else, I can always switch into it, but I could not switch into physics. So I thought I would give it a good, real go. And then it turned out I really liked it.
Do you remember maybe there was some particular like teachers who made an impact on you in a way that
People always want to have the kind of story, but
yeah, yeah.
actually, I really just like doing science
Ah,
and
okay,
solving
okay.
problems and things. I mean, there were, of course, people along the way who were influential, and I'm grateful to to my advisors and all of that. But it's not, I mean, that's the kind of story people love to hear, but I actually just really like doing the stuff. What was great about the school
That's
was
great.
it had really good students. I
Yeah.
mean, I grew up in Queens, which I don't know how that much means much to you. But it was a commute for me to get to high school. It took me over an hour and 20 minutes usually. But it was nice to go to a school where it attracted lots of great students, and it was nice to get out of Queens and go into Manhattan. I like that. And of course, it was good to be able to study physics at a young age, which you got to do at Stuyvesant. We got to, as sophomores, second year of high school, we could take physics. It was very nice.
The mystery is that in your field of physics, that you would love to see solved, maybe like in your
Oh, there's
lifetime.
many mysteries we want to solve.
Yeah, yeah, yeah,
And
some
one
kind
of the
of.
things I really like is as a theoretical physicist, I can work on a number of very different types of problems. Um, we still really want to understand the fundamental nature of matter, the standard model better, what particles are made of, where the Higgs mechanism that is responsible for the masses of elementary particles comes from. And is there anything that underlies it? I mean, we really do want to answer those questions, and it's challenging. There's theories, but we also want to have theories that we can test eventually. Another question, of course, is what is the nature of dark matter, the invisible matter that acts gravitationally like other matter, but doesn't have charge and doesn't interact with light as far as we know. And what are the consequences of those, in terms of structural formation, for example? Now we're considering a model of dark matter and how it could impact early black hole formation, as is seen by the JWST telescope. There's also questions about quantum gravity and black holes that we can, do with these theories, and questions about extra dimensions, which I certainly work on and try to use it as a tool to understand some of these other questions, but it's intrinsically interesting on its own. So there are just a lot of really interesting questions. Also, the cosmology of the early universe, if there are extra dimensions, what gives you cosmological inflation? Do we know anything about dark energy? That's an even harder question in some ways. So there's lots of interesting questions to think about.
Did you like writing at all in school? What inspired you to start writing like
Um,
popular science and
yeah,
to
I
do this?
know there were a number of things. I mean, one is that, I've been doing physics for a long time. I did some important work, and I thought it just would be, but I also realized I didn't like the way many of the popular science books were written. I thought they were sometimes arrogant, or they, would just sort of tell you. I just didn't. I mean, and I thought, well, it's very easy to criticize, but I thought, can you do better? So I just really wanted a book where people really understood the questions we're asking and why we asked them, and really just built you up to where we are today. And also, I didn't like the way, especially in this era where people are, argue about science and religion and all these things. I didn't like the way it was often presented as just so beautiful we had to believe it. I thought it was really important to talk more about the interplay between experiments, even if they take a very long time, and theory, and why we ask the questions we do, and how those questions actually guide us quite a lot. So there were also I just thought in terms of interacting with the outside world, this would be the best way to do it. To sort of start with physics, but it gave me an opportunity to have a little bit of a launch pad to speak about other issues if I wanted to. And of course, it was also important for people to know that there are women who do this field too. And if you just looked at popular science books, it wasn't so obvious. So there were just a lot of, but the real reason is because, when I started to write, I actually really liked writing. So that was another reason.
Maybe like such a silly question to ask, but when you appeared on the Times magazine, right, of 100 most influential
Yeah.
thinkers or something like this, what was that like? I'm sure you've been asked this like a
Well,
thousand times,
actually,
but
it was
still,
pretty funny because
yeah.
actually they left me a message saying to save the date. And I actually called, there's actually a reverse phone number lookup because I thought it was a scam. So, or I thought it might be a scam. So I just first wanted to check that it was real. But then, of course, actually doing it is a lot of fun. I mean, because of course you meet wonderful other people who are doing it, and it's nice to be recognized that way. Um, but I also realize that a lot of influential people are people who stay under the radar. So, because I think it's very nice for that to be said, but I think there are many influential people in the world you don't hear about.
Trying to put together like quantum mechanics and Einstein's theory of gravity. Do you think that like is string theory still valid in that kind of
I mean, look,
area?
string theory is a tool. It gives us some methods, it gives us
Yeah,
some
but
questions, but but we don't know what the ultimate theory is. But I mean, I like to do what I call effective theory, sort of trying to build up from what we know, combining it together with theories so we can make real advances. I mean, it's funny, we just had a conference on the work I had done with Raman Sundram and the work that followed, and also with Andreas Karch and the work that followed. And it was funny reminiscing, just how when we first wrote it, everyone, and especially, like string theorists told us it was wrong and they were wrong, or they said you couldn't find this in string theory and you could find it in string theory. So I think it helps to have different approaches that you're coming from the top down, but also from the bottom up, and that you actually listen to each other.
could you tell us maybe what kind of research are you involved in right now?
I just finished a few different papers. So one has to do with combining together something called supersymmetry with an extra dimension, and how supersymmetry breaking is communicated across an extra dimension. It turned out to be really interesting because it was something that had been studied from the lower dimensional point of view, like 3 dimensions of space plus one of time. Because of course, ultimately you want that theory to describe the real world. But the really interesting question is what distinguishes that theory from a theory that's purely 4-dimensional. But no one had actually worked it out from the point of view of the higher dimensional theory. So we did that and we found some interesting new effects. So that was really interesting. And there was another paper about inflation if there's an extra dimension. And that was done with Rashmish Mishra and McNee. And we considered like what happens if there's an extra, and the first paper was with McNee, by the way. And we considered what happens if there's inflation happening before the extra dimension is stabilized. And could we measure that in fluctuations of the cosmic microwave background radiation, for example? Like, would there be measurable effects from the fact that there's an extra dimension that hasn't yet been stabilized? There's another paper that I wrote with Hao Gang and Andreas Karch and Jesus, where we were actually thinking about global symmetries in theories that violate unitarity. That is to say, theories where you couple a gravity theory to a bath that doesn't have gravity. And could you have global symmetries in such a gravitational theory? It's a more formal question, but it has to do with the fact that people think there are no global symmetries in gravitational theories. So it was an interesting paper. So those are things that I just finished. It was pretty fun.
I don't know how much you could say about this, but have you looked at the future of science like as of this moment? Like, there has been a lot of like news that I've been reading about like cuts in funding of like due to the current administration.
Yeah, I'm actually quite concerned. I mean,
Yeah,
I
yeah.
think that we don't appreciate how much science does for us, and also how important basic science is, that it's not like everything just happened and we got all the wonderful results that change our lives. people were asking very fundamental theoretical questions, and eventually it led into these really nice developments. And right now, I mean, you just see a lot of cuts in funding, and it's quite worrisome. And I think I see my postdocs applying for jobs outside the United States, and it, even there's they're trying to disparage universities at some level, but also the agencies themselves are being cut. So it's really quite a problem. And I am concerned. I mean, right now, my group is great, but I am worried about the future, what's going to happen.
But like ultimately, do you feel optimistic maybe that it will just go on for a few years until like like president changes and maybe then it will
But
be.
even if the president changes,
I think
it's
the
much
impact would be
easier to
great.
destroy things than to build them up. And I mean, first of all, we're going to lose people. We're going to lose a generation, possibly. And also to restore the funding could take a long time at this point, especially if they would destroy the economy in the same time. So it's not at all clear that things will be back where they were. I mean, it's really a shame. Things were going incredibly well, and why break things that are not broken? But that seems to be what the goal was. It's very sad. You can destroy things quickly, but building them back can be challenging. And also, I mean, it's also hard because I think, to go into science or to do these other activities, often it's a challenging thing to do when you're making choices and sacrificing. And then if you think that it won't even work out, I mean, it becomes even harder for people. And so also that is one of the nice things about science. It's something that moves forward no matter, these other things are happening, but it makes you realize there's a bigger picture out there and there are important questions to think about. And so I think it can be helpful to remember that. And also just honestly, sometimes to remember how beautiful the world can be.
Would you have maybe like any message that you'd like to share with with us Ukrainians maybe on how to like handle this?
I mean, I guess one message is just that I admire you. I mean, one reason I agreed to do this is because we wish, obviously it's a terrible situation. It's such an unnecessary situation. And it's just so sad that this is happening. And that, this generation is being, overwhelmed by these external events, not to mention everyone else. I admire that people can still look forward and still be optimistic and still try very hard to maintain their values. It's a really amazing thing in light of everything that's going on. It's just really important to remember the importance of maintaining your individual values, even when you see societies go in different directions. And of course, sometimes it could be frustrating. And like I said, one of the reasons that was nice to write books was that sometimes it can give you more of a voice. And I think that can be important at times. And it's good that you're trying to have a voice as well. And also that to inspire people with what people are doing in science, because I do think that it's somehow hopefully transcends some of these political and social issues. I mean, I think religion serves different purposes. I mean, some are social, some are psychological, and so I think to the extent it does that, people will want to hold on to it. I think in terms of explaining the world, it's it's not for me. I don't think it would be the way to explain the world. But of course, there are many questions that I can't prove it, and so the only thing we can do as scientists is just try to see which are the questions we can answer, and the fact that we as humans cannot answer a question yet. I mean, we're not the all powerful. We are not God. So it doesn't prove that these things don't have answers. It just shows that we haven't answered them yet. So I'm not going to tell people not to be religious because I think it does serve other purposes. But in terms of understanding the world, I think science is a very good way to go. There's just lots of questions we haven't answered yet. And maybe and even seeing all the fundamental particles doesn't answer all the questions because there are different levels at which things interact, and sometimes it's too complicated. So I think we have to be more open to the idea that there's just lots of things we don't understand yet. And that doesn't mean that there's no explanation, it means we don't know the explanation. But the only way to find out is to try. So I don't have to decide this now.
As we're like approaching the end of this year, like people like to make maybe wishes for the next year, and kind of reflect on the past year. Do you like with everything that's like been happening to science like recently, like what kind of wishes you have for the like
I guess
2026?
I haven't really thought about that question, but I guess one thing is it would be nice if people appreciate what the benefits of having a scientifically educated population would be, and understand that the world will be better if they allow science to flourish.